Hello guys, could you please confirm whether you are able to hear me or not?
Yes.
I can hear you.
Perfect. Good. Okay. Okay, so guys, do you have any question until this point, or are we good to go to like next segment?
Yeah, actually, I just got admitted. I don't know.
Okay, so you did not attend first part.
No, I did attend the first part. The second part, I just got
Okay.
allowed in. Don't know what happened.
Okay. So yeah, means I'm asking about first part only. Like, means, do you have any question regarding that first segment? If not, then we will like get started with this segment where we will like discuss about. We will try to means.
So we were talking about the Python interpreter, right?
Sorry, I did not hear you.
Sorry, we were talking about the Python interpreter, right?
Yeah. So we will do tutorial on Python programming language as well. Okay. So just there is like this is just a theory that which is common to like all the programming language. I want to talk about that thing. I just want to make this picture clear in your head that like okay, so when it comes to any programming language, PCAP principle is like really important, and when you like think about or when you follow this principle, you would be able to like understand any programming language very easily. So that's something I want to deliver through this theory session, and then we will do a small tutorial about this theory part as well. So yeah, so in 20 minutes we will try to cover theory part, and in next 20 minutes we will try to complete that tutorial. Okay, so I'll share that link with you as well. So
Mayur, I have one question.
yeah.
Yeah, as you said earlier that we usually will use these two languages, Python and C++. But you mentioned that C++ is faster,
Right.
and it is used for this critical applications like where safety is important. So can you explain why if C++ is important, then why we are going for Python as well?
Okay, so thing is that
maybe with any example. Yeah.
Okay, so thing is that Python is like really easy to understand. Okay, it's too close to our natural languages. Okay, so like the way we have like syntax in English, Python is like quite similar to that. But when it comes to C++, it's quite difficult to understand, and it will take a long to master that thing. Okay, so if you're like able to write down, but if you're able to do particular task with like 2 or 3 lines of code in Python, you would need like 10 or 15 lines of code to do same stuff in C++. And thing is that C++ syntax is quite difficult to understand and like difficult to master. Okay, so that's the reason a lot of people are really not going for C++, means at least when they have to build their prototype. What they want to do is they just want to test their idea. So Python is simple, right? Python is something which is easy to use. It will allow us to like code like any idea very effectively and very easily, and that's something will like give us like idea about whether our idea or our particular project will work or not. But if you try to build that thing using C++, then writing code for that particular idea will itself be difficult, and then there will be like a lot of issues that you need to deal with. So that's the reason people are really not going for C++, and this is the reason for us as well. Okay, so we will try to learn this stuff using Python. Okay, obviously I'll try to conduct one session related to C++ as well, but you should focus on Python programming language for now. Okay, so that you will understand what exact means, how can we implement particular algorithm. Okay, so because what we want to do inside this coursework is we want to like learn about programming, and so basically there are 3 things, okay, which comes like in loop. So first is like you need to gain some knowledge. So you will gain knowledge about various algorithms that we need to build autonomous vehicles. Let it be related to perception, let it be related to sensor fusion, planning, or control. Then next thing is that whenever you are having any idea or whenever you are having algorithm with you, but that's not enough, right? You need to convert that thing into code. Okay, so you need to have like some sort of idea, you need to have like some sort of understanding on how exactly that algorithm or that sequence can be converted in, or logic can be converted into programming or like code. So that's where like knowledge about logic or data structures or algorithms, data structures and algorithms come into picture, and that's something we'll study into like next week. And then we will study about like this coding part in detail. So answer to your question is it's easy to implement that thing in Python, and that's the reason we are going for Python. But when it comes to deploying that thing on hardware, people, let it be in industry or anywhere, people prefer Python for prototyping, and people prefer C++ when they have to develop a code which is like running fast on hardware. Okay, so in that situation only they are going for C++, and means it takes a lot of time when you have to do some development using C++ framework. Okay, so that's the reason people prefer to go for Python and not C++ in the beginning. But yeah, means you can do in either way. But yeah, if you are somebody who is interested in perception part, who wants to work on deep learning project, then in that situation I would say try to learn about Python, because all the like APIs which are available out there to build a deep learning models, or like build means tools which work closely with perception part, uh, most of them are built inside Python framework only. Okay, so it's better to like learn this stuff in the beginning. Have I answered your question?
Yes. So basically it is like one language is difficult than another. And I guess there are more libraries available for Python than C++. So
Yeah, means it's user friendly. A lot of people have done development in using Python programming language, so you will see a lot of libraries, a lot of models over there to like do particular tasks, which is not the
okay,
case with C++. So there are like a lot of advantages to go for Python. But yeah, the simplest answer that I can give you is like, when it comes to building prototype, Python is preferred language because it's simple and it's easy to implement particular idea using this language. And when it comes to developing hardware friendly code, C++ is always answer.
okay, yeah. Thank you for answering.
Okay. So let's talk about, okay, so in the beginning I was talking about some theme. Okay, so when it comes to any programming language, there is a theme. Okay, so let's say you are okay, so you are starting with particular thing. So what you try to understand, what's the basic element for that particular thing, and then you try to put all those small things together, and you try to build complex system out of it. Okay, so if you consider our natural language over here, so whenever anyone wants to language, what we generally go for, we try to learn about words. Okay, that's the first thing that we do, because we consider word, yeah, alphabets are word, means we can use them interchangeably over here because we are just talking about units, or we can also consider them as a primitives. Okay, but when it comes to learning any language, what we try to do, we try to learn about words. Okay, and using that word we can like means you means anyone can like identify what exactly that thing is, but using just word we might not be able to perform particular task, right? We might not be able to perform any operation, or we might not be able to convey useful information across. So in that situation, what we need to have over there is we need to have proper syntax over there. Okay, so like what you need to have over there, you need to have like noun, verb, and noun over there. Okay, like a proper format. Then you would be able to like deliver some like I love Python or I like Python. So you would be able to deliver some useful information over there, right? In similar way, when it comes to programming, you need to think about of some primitive. Okay, so there was like famous computer scientist. You might have everyone should have like heard about him. His name was like Alan Turing. So in his research, he mentioned like there are 6 primitives. If we have to do any complex task, then the task can be done if we just like this, arranging these 6 primitives in proper order. And those 6 primitives are like moving left, moving right, reading, writing, scanning, and doing nothing. Okay, so these are the 6 tasks in which like he split this. He like proposed that like using these 6 primitives, any complex task can be done. Okay, so that's something he mentioned in his papers or like in his research. So when it comes to programming language, when we have to like express anything, let it be data or let it be any particular operation, so what we can say like means here also in programming language also we have certain primitives. Okay, so we will like talk about 2 things here onwards. First thing is related to data, and then second thing is related to operation, and we will call that as a procedure here onwards. Okay, so first of all, let's talk about data primitives. So in case of any programming language, there will be like certain data primitives, basic building elements that we need to consider to build or like build any complex data, means any complex collection. Okay, so basically those are data primitives. in case of the like programming, Python programming, we have like 4 data primitives. Basically, as you know, like we have like numbers, we have alphabets, and then we have like some decision making, yes or no. So basically, these 3 things are basically considered inside Python programming language using these 4 primitives. So first is integer. So whenever you are having like whole number with you, so you can use integer primitive over there, and you can like create collection out of those out of there to get like more bigger and complex data structure. Okay, so but primitive over here is a data. Whenever you are having a whole number with you, you will consider integer as a primitive. Whenever you are having like some irrational numbers or like whenever you are having like rational number with you or any number with like decimals, then in that situation you will go for like float primitive. Whenever you are having some sort of decision making involved in your like program, then in that situation you will consider boolean as your primitive. And then fourth one is a string. Okay, so whenever you have to think about any word, or whenever you have to think about any natural language thing, if you have to write down anything from your English language, so in that situation you will consider string as a primitive. Okay, so basically these are the 4 primitive which are there in programming language. If we master this 4 primitive, and if we like follow this PCAP principle, then we would be able to solve, or we would be able to scale it up to a level where we could solve any complex problem. Okay, so but what we need to do is we need to understand these primitives very well. The reason I have mentioned these primitives over here, because in case of the Python, you really need not to mention data type for your particular variable or element. Okay, but when it comes to other programming language, in that situation you need to mention your data type, because all these data types have their own memory requirements. And when you define particular variable using these data primitives, that much space will be allocated for your element on like memory, in memory. Okay, so that's the reason we have to understand about these data primitives in like much better way. Okay, so basically there are like 4 primitives that you should consider when it comes to data. And then let's talk about second segment that's related to procedures. So as you all know, basically what we do whenever we are having some elements with us, whenever we are having numbers with us, what we generally do, we can like do addition, subtraction. So we try to perform mathematical operations on it. Okay, so these are like simplest operations that we could do, and using which we would be able to do like, means if we like stack all these operations one above other, then we would be able to get like particular complex task done. Okay, so basically that's like simplest operation that we consider. So in case of the programming language, there are certain primitives which belongs to category of procedures. Okay, and those primitives are those procedure primitives are, first is mathematical procedural primitives. Okay, or basically we can call that as an operator, because these are basically operators which operate on like 2 data elements and then give us like some sort of output. So we have mathematical operators in the form addition, subtraction, multiplication. Then we have comparison operators. Then we have logical operators. So this is something which operate on data. Basically, we are doing some sort of operation over data, and then we are giving out some sort of output. Okay, but these are the primitives. Okay, so when you think about any programming language, just try to think about that programming language from the these 2 lenses. Okay, first is for data and another one for procedure or operation. So at the level of primitives, we have like this integer, float, string, and boolean. And for procedures, we have these operators. Okay, just give me a moment. Okay, so yeah, sorry for that. So basically, we have these primitives with us. And when we so thing is that when you talk about any programming language, as I mentioned in the beginning, the theme that we should all consider is like modularity. Okay, so when we try to think about any programming language, we should have like some submodules with us. When we put them together, we would be able to like get like bigger module. Okay, so composition should be property of our programming language, and that's the case with like most of the programming language out there. So that's like second principle that I want you to remember, and that's about combinations. So when you combine these data primitives, or when you combine these procedural primitives together, you would be able to get something more, which is something much more evolved and complex than like simple data elements, and you would be able to get like much more tasks done using these combinations. Okay, so just try to put this thing into two categories again. So when you combine data primitives together, you would be able to get data structures, and when you combine procedures, basically these are like simple operations. When you combine a lot of operations together, you would be able to get like some sort of program or like some sort of task done. Okay, so basically that's like control loops and simple sequences of operations. Okay, so these are the two categories. When you combine data primitives, you would get data structures. It will again have two categories: simple data structures of the form like tuple, list, dictionary, and set. We will like see tutorial relate that as well. And when you again put that element together, when you again create collection out of it, then you will have like complex data structures in the form of like you will have array over there, then you will have linked list over there, you will have stack queue, you will have then you will have trees over there. So as I mentioned earlier, like we have dictionary, but when you try to like play with that thing in a graphical space, you would have tree over there. Okay, so tree will again have like some nodes and branches and a lot of stuff. Okay, root and branches and all that stuff. But when you just consider like two branches, and so it will convert into binary search tree. So in that situation, we can represent the tree using array, and you will have heap over there, heap data structure. Then again, so thing is that when we talk about all these complex data structures, and let's say we have really huge data with us, so in that situation, accessing any element from the data structure would be quite hard. So in that situation, to speed up this process, we go for hash maps. Okay, so I'm talking about this element over here. Okay, so we will have like hash maps over there, and then hash maps will means to get that hash map, we need to have like hashing function with us, then hashing function, then we need to have like some mechanism to deal with collision, and then means a lot of stuff will be there. But basically you will have hash maps, and using that hash maps, you will be able to get that access very easily. Okay, so we will do tutorial related to that as well in next week, means related to all these data structures. And then we will have graphs. And yeah, graphs is really important thing when it comes to autonomous vehicles, because our entire path planning algorithm works on graphs. Okay, so you should understand that thing thoroughly. And then there are algorithms, that's something I haven't mentioned. So data structure is one thing, and when you combine a lot of operations together, you will get like this control loops and simple sequence operation. Okay, so you will have like for loop, while loop, and then this if and else loop over here, as well as you will have like some other simple operations that you would do inside procedural programming. All of that stuff will fall into this, even in functional, not in functional category. But yeah, if you follow procedural programming style, then all those simple programs will fall into this category. Okay, when you combine like simple procedures together, you would have like these combinations, and you would be able to express yourself more conveniently. Okay, so this is about combinations. Okay, so this is something I'm trying to like create in your head. Like, so we will start with data, then we will combine that together, we will get like some complex data structure or procedure. We will move further, and then we will have like some abstraction on top of that, so that we could play with that data structures and procedure in more elegant way, and we would have like more means we could get like more out of that. Okay, so I hope like you are clear about data structures and procedure. So at this moment, we are at the stage where we have like complex data structures with us, means whatever data is there, we would be able to express that thing properly using data structures. And whatever sequences or operations are there, we would be able to deal with them using these procedural combinations. Okay, or using that composites. So next thing is that, so thing is that in the beginning also, I mentioned about, for any programming language there are two principles that it needs to have. First is the modularity, so that it would be easy for us to scale up, and second thing is the abstraction. So abstraction is necessary because let's say we build particular element, and if we want to use that element again and again and again, so whenever there is a repetition over there, so in that situation, this abstraction principle or abstraction property comes handy. Okay, so again I want to like split this thing into two categories: abstraction related to data and abstraction related to procedure. Okay, and then there is like third category over here as well, which combines data and procedures together, and that's something we call as like class. Okay, so thing is that when it comes to data, so what we try to do, so as I mentioned in the beginning, data is something where we have like like some elements with us, and when we do combination over there, we will get like complex data. But in order to understand that value, what we need to do, we need to associate that value with some sort of names. Okay, so naming that value is something we call as a variable assignment, and that's how we are doing abstraction. Okay, so let's say whenever I'm writing b is equal to 2, what basically I'm doing is I'm trying to assign, like, means what I'm trying to do over here is I'm trying to use that 2 value again. I want to use that 2 value again. Okay, so when I write b is equal to 2, and if I use that b again, then I would be able to get that 2 value again. I need not to write that 2 value again. Here I'm just giving you like simple example. Okay, so let's say instead of 2, if I'm using like some sort of float number 2.1345, so in that situation, if I have to use that value again, I need not to write down that value entirely. Okay, if I'm using some sort of string, so in that situation also I really need not to use that string. We need not to write that string again. We just need to use that variable, and that's the beauty of abstraction. Okay, so whenever you are having any sort of element with you, and if you use, or if you assign, or if you associate any sort of name with that value, then it would become easy for us to use that value again and again and again. So this is the third property that any programming language should have, and all the programming language that you will see. So most of them programming, why most? All of them have this principle. Okay, so they makes abstraction quite easier. Okay, so that's related to data, and let's now talk about second category. So that's related to procedures. So far at this moment, what we mean, until this point, we are able to understand simple operation like addition, subtraction, or logical operations, or like operation related to comparisons. Okay, but this operation will not be able to like solve really complex problem. What we need to do in that situation, we need to stack those operations over each other using that combination property, and we would be able to solve that thing. But thing is that, so there is like certain sequence, right? But if you have to repeat that sequence again, so in that situation, if you don't use this abstraction property, then what happens? We will need to write that entire sequence again. So in that situation, this property of abstraction comes handy. And so if you want to see equivalent of this thing over here inside our Python programming language, then we call that thing as like function definition, or like defining a function. So whenever you are defining function, what basically you are doing is you are assigning name to sequence of operations. Okay, I hope this thing is clear to you. Okay, so first of all, what you do, you try to assign name to data structure or data. Then you try to assign name to sequence of operation which are encapsulated inside function. And whenever you want to use that sequence again, so what you need to do, you just need to use that function name. Okay, for next time. So that's the beauty of abstraction. And the next thing is, when we want to use data and procedure together, so in that situation we can also do that thing using classes. Okay, so classes thing where we could combine data and procedure together. Okay, so in the case of class, we consider data as an attribute and procedure as a method. Okay, and these two things allow us to like deal with these sequences of operations and all that stuff like very easily. But class is something using which we can define any subsystem or like simple process. Okay, and when you have, okay, so this is about abstraction. I hope this thing is clear to all of you guys. Is this thing clear to you, or do you need like some explanation regarding that?
It's clear from my end.
Okay,
fine. Yeah, it is clear for me as well.
Perfect.
Yeah, clear.
Perfect. Thank you. So now let's move further. So thing is that until this point, what we have done, we have defined simple subsystem. Okay, we have defined simple process, or let's call it like let not call it process. Let's just call this as like subsystem. Okay, and let's say we have some process which involves implementation of a lot of subsystem one after another. So that's something we call as like process. Okay, so whenever we have to implement such complex process, so in that situation we need to implement these subsystems a lot of times. So in that situation, this fourth property comes handy, and that property is like called as a patterns. So basically what you are doing is you are trying to create templates of your data structure. So you're trying to create using that variables, you are trying to create templates of your procedure using classes or functions, and then you are using those things repetitively inside this process or process to get your desired task done. Okay, so if you are using definition or like classes, then you would just be able to solve simple subsystem. But when you use this property of patterns, when you try to develop super class out of that particular class, or when you try to develop a really elegant class out of those functions, then you would be able to develop or solve really complex problem. Okay, so this thing is clear. Okay, so whenever any complex problem is there and whenever we have to solve that thing, we need to use all those four properties together, and if we use them properly, then we would be able to solve that complex problem very easily. Okay, this is about Python programming language, this is about C++, and this is about every programming language out there. So now let's talk about processes which are out there. So there are certain processes which are static, means there is no transition condition check over there. Okay, while moving from one subsystem to another, and you can just tag them one above another. You can like call you can call instances of those classes one after another, and you would get like implementation done very easily. Okay, you would get that process implemented very easily. So those are static processes, and we can implement them very easily using super classes. But when it comes to dynamic processes are the one which involves transition condition check while moving from one state to another state. So in that situation, we cannot just rely on like these simple means super classes and all that stuff. So in that situation, we need to use state machines. And I will also show you like means implementation of this thing in like next lecture or maybe next week, how exactly state machines can be implemented. But the only thing that you should understand over here is like whenever static processes are out there and whenever you have to solve that thing, you can solve that thing using super classes. And whenever there are like dynamic processes, like let's say you have account in one bank, and you're like for every month you're like depositing some amount into that account or withdrawing some amount from that account. So in that situation, this process become dynamic. Okay, so if you have to deal with such sort of processes, then means in that situation you need to solve that thing using state machine approach. So that's the thing. And all the robotic processes that you would see, so all of them are generally like dynamic processes. Those things are like changing quite too often. Okay, so and whenever we have to solve those problems, then you need to go for state machines. So that's about patterns, and these are the four principles that I want to that like we have seen. So like when we have to learn about.
Excuse me, Mayur.
Yeah.
Sorry to interrupt you. Can you go to previous slide?
Yeah.
Yeah, I am not clear about these patterns, and like you explained processes. So how these processes and patterns are related? What is the relation between them?
Okay.
Can you just explain it once?
Yeah, definitely. So thing is that process. So when I talk about any complex system, basically that is a process. Okay. So process is alternative name for complex system. So what I'm trying to say over here is whenever I have to solve any, whenever I have to develop or whenever I have to solve any problem related to complex system, then I can solve that problem using principle or property of patterns. So what pattern talks about? Pattern says whatever classes that you have created using this, whatever classes that you created over here, or sorry, whatever things you created over here at this abstraction stage, you just need to use them. You just need to convert them into some sort of templates, and you need to use those templates again and again. Okay, so you need to understand pattern over there. Okay, you need to understand pattern in your process. You need to consider that as a subsystem, and you need to put those subsystem one above another. You need to put all those templates one above another. Is this clear, or should I draw something?
So that means like we have to arrange these processes in specific pattern, right?
Yeah, exactly. So you just need to like express that particular process in the form of these templates. Okay, and basically these templates are nothing but patterns that you are trying to understand in your process. So whenever you look at particular process, so basically what you need to do, so it's not about programming, rather it's about approach in which you can solve that particular problem. So you need to split your process in like set of patterns or set of templates, okay, which you could use to solve that problem. Okay.
Okay. Now it is clear. Yeah. Thank you.
Yeah. Thank you. Okay, so and then these processes are two types: static processes and dynamic processes. Like when you go from one subsystem to another subsystem without condition check, which are really not changing too often. So in that situation, we will consider that as like static processes, and that something can be solved using super classes. When that's not the case, when those like there are transition condition check being implemented or like being executed, in that situation we will consider as like dynamic process, and that's something need to solve using state machine approach. So that's a different thing. That's something we will see in like next lecture when we discuss about programming styles and state machines. Okay, so the only thing that's remaining at this point is like you are clear about programming language. Like when we have to solve anything using programming principle, what we generally do, we try to split bigger thing into smaller things, and then we try to deal with that smaller things. Okay, a little bit about data, a little bit about procedure, and then we try to put them thing together, and then we will get like bigger problem solved. But thing is that how exactly we can keep track of all these things? Okay, how exactly keep track of let's say there is a data and we are saying like we are assigning some sort of name to that data, we are doing abstraction for that data, or we are doing abstraction for a particular procedure in the using some functions or using some classes. We need to keep track of all that thing, right? So that something is done using this environment, binding environment. So basically what it does, it try to associate all those entities which are there, let it be data or let it be procedure, to certain names, and then store it inside computer memory in the form of dictionary. Or if you have to like if you're looking for some sort of equivalent, then you can consider that as like some sort of list. Okay, in left column you will have like names, and in right column you will have like values. Okay, so just like this form. Yeah, my bad. So basically you will have like names over here. Names over here, and then you will have like entity over here. So when I say b is equal to 2 inside my editor, so basically what I'm saying is like b, that's a name, it means I'm creating this list, and I'm saying b is my name, and like I'm associating this thing with like 2. Okay, so basically I'm creating dictionary out of this thing. Okay, so whenever I key in this like name thing over there, we will get this entity 2. Okay, so this is about data, and means whatever sequence that we are trying to execute. So for like whenever we are doing like particular operation, so whatever value generating, so all those value track of all those things will be like kept inside this binding environment. So basically just trying to associate these names with some sort of entities, let it be data entities or let it be procedure entities. Okay, so this is our data. So for data it's like simple, like you will have name in like left column and you will have value in right column. But when it comes to procedure, so in that situation what it does, so let's say I'm defining some sort of function, and I have to like add this, or I have to create binding for that thing over here inside this binding environment. So what I do, I'll create like some name over here, let's say addition add. So basically that's the name of my function, and instead of adding some value over here, what I do, I try to add some pointer over here. Okay, so pointer is a variable which basically stores address of like another variable. Okay, so basically this binding environment is something will be created inside your stack memory. So when it comes to stack RAM, basically there are two memory segments. Okay, so first is a stack memory, and then there is a heap memory. Okay, so all the secret means all those volatile operations or all these like frequent operations are being done, or like all this storage is done. So that something will be done inside stack memory, and this binding environment is also created inside the stack memory, and that memory is quite limited. Okay, so that's the reason in some situation you might say like means we cannot perform this operation due to memory limits or something like that. Okay, but when we call any procedure, or whenever we like include procedure inside our sequence of operations, so in that situation it will add name of that procedure to name segment, and instead of adding entity over here, it will add pointer over here. Okay, so basically it will store address of like first element inside heap memory. Okay, inside this binding environment, and at that new location, so let's consider this is a stack memory, then you will have like this heap memory over here. Okay, and inside that heap memory, no, it's not working. Okay, the way you are having So if you consider this as like stack memory and our binding environment is getting created, obviously in all the situation it will always be created inside stack memory. But whenever there is like procedure over there, whenever you are calling any function or subroutine, so in that situation it will store pointer over there. Basically that's like address of variable means address of this first location over here. Okay, and that's something will be in your heap memory. Okay, and then inside this heap memory you will create second environment, and all those things which are there inside that function will be stored over here. Okay, all those data elements, all those procedures will be stored over here. And let's say if you are using another function over here, then environment E3 will be created. If you consider this as the environment E1, which is inside stack memory, we are calling another environment E2 over here. If we are using like some function over here inside this E2 environment, then we will again use pointer over there, and then it will direct us to like environment E3, and then all those variables will be there. Okay, so basically this is the idea about binding environment. Then you might ask like, what's the use of this binding environment? So we use this binding environment to access any data element easily. Okay, so let's say at line number 2, if we are defining b equal to 2, then inside binding environment this thing will be created. Okay, but if we use like b at line number 70 or line number 1000, then it will like easily give access to that value 2. Okay, just because we have added this thing inside this environment. Okay, that's something we need to consider. And since we are creating this thing inside the stack memory, whenever execution of particular procedure is done, this environment will be destroyed. Okay, so that's something you need to keep in mind. So that's all about binding environment. Binding environments is something which associate data or any sort of entity, let it be data or procedure, with some name, so that we could access them easily whenever we need them in later stages. So basically this is all about Python programming language, or like things that we consider in programming. Okay, so the thing that you should learn from this lecture is what is the principle with which any programming language is built, and basically that's the PCAP, primitives, combination, abstraction of those combinations in order to access that thing easily, and then use that thing in the form of templates using pattern property to solve bigger problem or process. And then what exactly is allowing us to get that data or that abstraction done very quickly. So basically that's the binding environment. So these are the things that you need to keep in mind. Okay, and I hope these things are clear to you. If these things are clear to you, then probably we can go for our tutorial, and then we will try to finish that thing in next 10 minutes if possible. If this meeting ends, then try to join this meeting again using same link. Okay, second link only. Guys, do you have any question at this point, or are we good for tutorial? Shall we go to tutorial?
I don't have any questions.
Okay.
Yeah, we can go to the tutorial.
Okay, so in that situation, I'll share link for the tutorials with you all. I probably have shared that thing with you. So here is a link that I shared with you all. Try to open this thing in your browser, okay, and it will guide you towards like this sort of tutorial. I'll also try to open this thing on my side as well. So try to open this thing on your side. Guys, it will take another 20 minutes. Okay, so yeah. So if this meeting ends, just make sure like you are joining again using same link. Guys, can you see my screen? And are you able to open this particular file on your system?
Hello.
We can see your screen, but like, can you
Yes,
share that link in chat?
Yeah, I have shared that link in chat only.
Yeah.
Okay, so you are able to open it, no?
Yeah, yes.
Perfect, perfect. So, so this tutorial is to just practice what we have learned in theory. We are here to practice that PCAP principle. And
Mayur,
yeah.
can you share it once again? I guess I have not received it on the chat.
Yeah, even I have not received.
Okay, okay. Just give me link. Copy link. Okay, Sarah has shared that thing in chat. Thank you, Sarah.
Welcome.
Okay, so this is a tutorial, guys. Okay, so I have created this tutorial just to practice things that we have learned in our theory lecture. So in the beginning, if you like, so thing is that this is a Colab environment. Have you heard about this Colab environment? Like, okay, let me tell you. So Colab environment is something which we can use to write code in our browser itself. Okay, so this is something is hosted by Google, and that's something we can use to write code over here. I mean, code in Python. So instead of using editor on your own system, we can do this code writing thing in browser itself. So that's something we are doing right now. So here you have two options. Okay, you can add text in the beginning, the way you write comment. So instead of writing comment, you can directly add text over there, and you can like explain what exactly you're doing it like inside your code. And then there is stage. If you click on this button, you would be able to add code over there. Okay, so using these two things, I have like created this tutorial. So I have added some information in the beginning. Okay, so thing is that as I mentioned in the beginning, Python is an interpreted language. So whenever you execute any code, so what happens after initialization stage, it try to it will fall into this interpretation loop, and then inside interpretation loop, it will like it will try to like go through these steps. Okay, and it will go through those steps again and again. Okay, so first thing interpretation or interpreter do is like it try to ask user what means, try to provide some sort of instruction. Okay, so it will prompt user for input, then it will read what user has provided as an input. Then third thing it will do, it will try to evaluate. Okay, so it will try to see what exactly user has provided and what exactly this system or companies he has understood from that thing. Okay, so if user has said like 2, then this interpreter will interpret that thing as like, okay, so you have entered integer 2. Okay, if user has provided some sort of link like I like Python, then this interpreter will interpret that thing like like you have entered some sort of string over here. Okay, so basically it is trying to evaluate the expression that user has entered, and it could be like simple expression or it could be complex expression, but these are the things which are being evaluated by our interpreter. Then if once that evaluation is done, it will try to pop up, means it will try to display those results to the users. Okay, so that something is happening, and then it will keep on doing that thing again and again and again. So basically it's like that play that's happening between that control unit and arithmetic and logic unit. Okay, so that's something is happening over here using this inside this Python interpreter, and this loop will like keep on going again and again and again until we are not done with like entire execution of our code. Okay, so basically what we need to do, so inside this interpreter we need to prompt the user, like you need to provide some sort of input. Okay, and whenever our program has to talk to user or like any sort of means outer world, so in that situation the platform it will use is something called as a console. Okay, like screen of our computer or display. So whenever it has to provide, it has to like display some message on that console, it will use command print. Okay, so this is a command that you can see over here. So syntax is something like print is a keyword, and then you will use parenthesis, and whatever thing you want to print, it could be variable, it could be like direct string, you can keep inside that parenthesis, and you can print it to, or you can display that thing to console. Okay, so I have written this simple string over here. Okay, and that's welcome, and when I run this thing, I just need to like click on this button, and it will like run that cell for me, and you can see result over here. Okay, it is equivalent to running code on your system. It's like you are writing this thing on your shell, and then shell will execute that thing and it will give you result. So this is something happening over here. Okay, so this is about printing. Okay, whenever you have to write something to print console, you will use print command, and whenever you have to read something from your console, you have to read something from your user. So in that situation you will use this input keyword. Okay, so input and then parenthesis, and inside that parenthesis you will put something. So only thing that you need to remember is whenever you use input thing over there, so always our interpreter is considering or expecting string as an input. Okay, so over here let's say if I write something, then it will like means it will ask me for like some sort of string as an input over here. So basically I need to provide that thing, and it will print that thing. Okay, so whatever I write over here, it will be printed, because what I'm doing over here is, as I mentioned in the beginning, means I will talk about primitive and all that properties over here. Just I want to talk about this thing where we are displaying signal to console, and when we are reading from console. So we are displaying using print command, and we are reading using this input command or keyword. But thing is that we are always expecting it to be string. Okay, and we are storing that thing into a variable. So abstraction is being done over here, and then we are printing. So you are able to use this thing A again without having to like consider this entire string over here. Okay. So basically that's the thing. But thing is that, as I mentioned, like it's always expecting it to be string. So when you enter some number over here, and if you want to display this thing, or if you want to use that number in your operation, you need to cast that thing. Okay. So int is like our means data type over here. So when you use int in the beginning, so that's something called as like means you are doing conversion, data type conversion. So that thing will be like converted from string to integer. Okay. So let me run this thing. So in first block, what we are doing is like we are running this operation, or we are running this command. So if I write Mayur over here, and if I enter, so what I'm doing is I'm assigning this string Mayur to variable A, and when I print this thing, it will print Mayur over there. Okay, so you will see second thing, it has been printed by our like this console or like our system, and now it is at like this stage. Over here, what it is asking us to do is like it asking us to like provide some sort of number over here. Okay, so it will expect this to be like string. So if I write like 23, then it will be like considered as like some sort of like a string. But if you have to display that to be as a number, so in that situation, what we need to do, we need to convert that thing from string to integer. Okay, so that's the reason we are doing this conversion using this int command. Okay, so you can convert that to float, you can convert float to int, or like you can convert that to bool as well. Okay, boolean as well, and that thing means that conversion has happened. Okay, so basically that's about writing to console and reading from console. I hope these two things are clear to you. And we use print command to writing to console, and we use input command to read strings from console. And to do data conversion, we use data casting procedure. Like we use either data type int in the beginning, we use float, or we can use bool, means BOOL, means as a some sort of keyword over there, or we can use str over there to consider it as a like some sort of string. Okay, but yeah, that's the thing. So I hope you are clear about this thing, how to write to console and how to read from console. The next thing is,
So I had a question. This is Ranjit Mayu.
yeah.
So you used double quotes and single quotes, right? Like what's with that? Like for
So-
print, you use double quotes over there, and here in the
Okay, let me tell you what happens. So thing is that string is like kind of complex data structure. Okay, so basically, you know, in English language, let me give you example of natural language. In English language, we have alphabets, right? So whenever, and equivalent of that thing in C+ programming language is character. Okay, CHAR. Char is like data type that we use in C++ programming language. And whenever we are dealing with that character, we can put that thing in single quote. Okay, means that's like just some sort of how do I put it, some sort of standard or like habit that people keep. Okay, so when they have to deal with this, if you're asking about this input string over here, then that's a different thing. Okay, but if you're asking about printing, so whenever you have to print some sort of character, so you can use single quote. Whenever you have to print like bigger string, like string is basically kind of phrase, right? So you will have like number of words over there. So whenever you have to print any phrase over there, so in that situation you can use double quotes.
Okay, so double quotes are for like single words, and if you want a phrase like a sentence, then you use a single quote. Is it?
No, it's opposite of that. So whenever you are whenever you want to use like single word or like single alphabet, so in that situation you will use single quote. Okay, and whenever you want to use like words or like phrase over there, number of words over there, so in that situation you will use double quotes. Okay, this is just the norm. Okay, so it's not like that, like if you use single quote it will not work, but this is like standard thing that we, at least I'm trying to follow.
Okay, and like when you say enter the number over there, like I mean you have used single inverted comma over there, right? So what?
So basically this is the syntax for this input command. Okay,
For input. Okay.
so like it is expecting,
double inverted comma.
yeah, it is expecting that input to be string, input to be like some sort of string always. Okay, so in Python programming language we are really not doing differentiation between string and character, but that's the case in case of the C++. Okay, but in Python we are really considering both of them as like single thing only, a single data type. The way we consider list and array as a single thing in Python programming language, but that's not case in C++. In similar way, when it comes to strings and character, we try not to do this differentiation here in Python programming language. So this single quote is like part of that command itself, I believe, because this input, this keyword itself is expecting that to be some sort of string. Because if you use this thing like means if you remove this int from here over here, what you will see is like, and if you like check type of this B, okay, so if I remove this int from over here, and if I check type of variable B, then see what it says. Man. So what it's saying is like variable means data type of variable B is string. Okay, so as I mentioned, like it's not differentiating that thing between string and character. But even if you have entered number 2 over here, but still it is identifying or recognizing that thing as a string, just because input command always expect input to be string and not as an integer. But if you change that, like if you add int keyword over here, then check what happens. And if you check like that thing, then it will like show that's like integer. See, class is int. Okay, I believe this thing is clear to you. Let's move ahead. We have a lot of things to cover, man. Okay, so next thing is like writing comments. Okay, so in each programming language, comment is an important thing because that's something allows us to explain our code in like properly. Okay, so that whenever somebody else try to read that code, that person will understand what exactly is being implemented over there. Okay, so that something is over there. Whenever you are having like single line over there, you can use like hash as a keyword and you can write comment over there. Okay, so over here I have written like hash and then print welcome. So basically I have created this line as like some sort of comment. Means that thing will not be executed. Okay, so it will not consider what's after this hash thing. Basically that's like comment like for single line. But whenever you have to write like means more description of your function, so in that situation you means whenever you are having like comment which is like of more than one line, so in that situation you prefer to have strings over there, doc string over there. Okay, so you basically use like this three combinations of this double inverted quote, and using that you can write like more explanation of this definition function. Okay, what if here I have just written like hello friend do study hard, but that's not the thing. Basically what you write over here is you try to explain logic that you have implemented inside this method or this function. Okay, you mentioned like input is like this is the input that I'm expecting, this is the thing which is being implemented inside this logic, and this is output that I'm you will be getting. Okay, so basically these are the two things which you can include in your code: comment using hash, and docstring or explanation of your code using this thing. Okay, and this is a function declaration as well. Okay, so I have declared simple function. So definition is a keyword, Mayur is the name of function, and I'm providing no argument over here. Basically you can provide argument, okay, as some sort of input to that particular function, and you have to just follow this syntax. And what I'm doing over here, I'm just defining a is equal to and returning a. Okay, so this function, what it will do, whenever I call this Mayur function, it will return two value to be. Okay, but in order to print that thing, I need to store it in some variable. Okay, so if you see this line, if you have checked like a lot of Python code, you have noticed this thing. Okay, so if underscore underscore name underscore underscore. So basically what it does, it try to take you to that point where that's where like execution of your code start. Okay, so basically what it does, it try to start execution of your code from this main comment, and then first thing it sees is like we are trying to create instance of this function. Okay, Mayur, basically we are trying to create object of this thing. Okay, so I am creating object of this thing by calling this function, and I'm storing this thing in B, and I'm printing B. So if I just if I not write B over here, then I will not see 2. Okay, when I run it, but when I store it in some variable and if I print B, then I will get like this thing. Okay, so basically this is about comments and function. I believe you are clear about how to write comments using hash keyword, and how to write docstring to explain your code properly.
Mayur, one question here. Here, like you have printed B, right? So won't it be a better solution if you provide the return here itself and then just call?
Yeah, it's possible.
Yeah. Okay. Yeah.
Yeah, it is possible. Means I'm just trying to show you like how exactly Okay, what I'm saying is like, if you put this thing inside this print thing, it will work. Okay, but if you remove this
Okay.
B thing altogether, if you like create comment for this thing, and if you remove this B thing from here, so basically what you are doing over here is you are also calling this Mayur function. So in
Right.
principle, you are supposed to see 2 over here. Okay, but this is something will not happen because it is not being stored in some variable. Okay, so it's not getting like what to display.
Okay.
Right?
Yeah. Correct. Correct.
So that something is happening. Okay.
Okay.
So that's about writing to console and then reading from console, and then again to again how to create comment and how to create docstring and how to create function and all that stuff. Now let's discuss about like primitives. Okay, so these are the 4 PCAP principle. So let's start with first thing. As I mentioned, the first data type that we have available inside Python is a integer. So whenever we are having like full number with us, we can call that as integer. And what we are doing over here is with this line d is equal to 2, we are keeping we are storing this value 2 in variable d. Okay, so we are creating this binding environment in which we have like d as a key and 2 as a value associated with that thing. Okay, so basically that is like integer. Okay, print d, so it will print 2 whenever e is equal to 2.1. So that's like second data type, that is a floating point number, since you are having the decimal point over here. So that's like another data type. So that is a float. Whenever you are doing some sort of like comparison, or whenever you are having some sort of decision making over there, so here what I am checking whether d is greater than e or not. Okay, since 2.1 is a, sorry, 2 is not greater than 2.1, it should return false. Okay, so that something is provided over here, and that's something we are storing inside this f variable, right? So that is a third data type that we are having. First is an integer that you are seeing with which is stored inside d variable. Second data type is a 2.1, which is stored inside variable v. That's something we are calling as like float. Then third is a boolean. Basically that is a true false value or zero value. That's something we are storing inside variable f and we are printing it. And then fourth is a string. So basically these are like primitive data types that we use. So whenever you are writing this thing, we will write in single string and I'll print it. Okay, and whenever you have to change this data type from like one to another, you can simply type like means integer or like that keyword, int keyword, before that variable, so that that variable will be converted into integer. So if you see e over here, then e is a float. Okay, means it will be like represented as 2.1. But when I cast int before that thing, okay, so data type of e will be converted into float, sorry, integer, and you will not see 0.1 over here. Okay, so if I print this thing, you will see for e value, sorry, value of e is a 2, means we have like it has like remove that 0.1 part. And if I change data type of d from integer to float, and if I like cast this thing using this float command keyword, then you will see decimal dot 0 is being added over here. Okay, so basically what you are doing is using this integer float keywords, you can change data types. So basically these are the 4 data types, and using this casting thing, you can change data type between like these 2 things. And this is true for other things as well, for complex data structures as well. Let it be like list, tuples, set, or a dictionary, you can do that stuff. The next thing is procedural primitives. So as I mentioned, so procedural primitives like addition, subtraction, multiplication, division, remainder, power. Then we have like comparison operators, and then we have logical operators or the form and, or, and not. Okay, so we will try to just see. So basically these are the mathematical operations which we perform. Like we can do addition, we can do subtraction, we can do multiplication, division. To get remainder, we will use this percent sign. In order to get power, we will use like double star. Sorry. Yeah, I thought like, oh, it's not visible over here. Okay, so we will use like this double asterisk sign over there, and then to perform operations like comparison operations, we will use like this greater than, less than, greater than, equal to, less than, equal to, equal to, or not equal to signs over here to perform some comparison. And for logical operations, basically this is something we need when we are performing like if else conditions. Like whenever we want to check 2 things simultaneously, we will use and keyword between these 2 conditions. Whenever we want to check either of them, then we will use or keyword between them. And whenever we want to get inverted of that particular thing, then we will use not thing before that. So basically this operation is something I have performed over here, d on d and e variable. Just run it and you would be able to see like result of that thing. D by e is supposed to give remainder, which is giving us a remainder of 2. Okay, because 2 means 2 by 2.1 means we will get that thing as 2 is the remainder. Okay, right? And then like d asterisk asterisk 2. So basically this is something giving us like power of d square of value means value which is we have stored inside variable d. So just run it and you would be able to see this like procedural primitives. Then next thing is we combine these primitives together and we would be able to get like data means composites. Okay, so when we combine data elements together, we will get like some different collection. So if I'm having like integer as like basic element, and if I put like a lot of data elements this integer together, then it will be like some sort of collection, right? Then that collection will be considered as like simple data structure. And when we put this thing inside parentheses separated by comma, then that will be considered as a tuple. And when we put all these things inside square bracket, then that will be considered as a list or Python array. Difference between tuple and list is tuples are immutables, means you are really not able to change any of this value over here. But in case of the list, you are able to change that value. You can access this thing from over here. Okay, so basically at this line, what I'm doing is z is equal to 1, 2, 3. So basically, I'm creating tuple of 3 integers, and at this line, what I'm doing is z square of inside square bracket 0. So basically, in case of the Python programming language, indexing start from 0. Okay, so we are starting from 0, so it will provide me first element, and that something is provided over here. Okay, 1. Inside a list, again, second element is the 1, means this we are creating this list. We are keeping everything inside square bracket, and if I keep means if I ask for like if I have asked y is equal y inside square bracket 1, it would have written 3. But what we are doing over here, we are doing some sort of means this assignment over here. Okay, we are changing this 3 with 5 using this command y square means inside the square bracket 1. Basically what we are doing is we are changing this first element with value 5, and if I print that thing, instead of printing 3, it will print 5. Okay, then we have set. So as you know, set is like a collection of unique element. So here I have created 1, 1, 3, 4 as like collection, and when I print it, since it is a set, it will skip that second one. Okay, because it needs all those elements to be unique. And then we have dictionary. Basically dictionary is something which is a combination of these set principles and like set and this list. Okay, so what you will have inside dictionary, you will have key value pair over there. Okay, so basically you will put everything inside this curly bracket. For set also you will put inside curly bracket, but over here is what you will do, you will put everything inside curly bracket, but you will use like 2 things over there. You will use key over there, which is inside inverted block, and then you will, after this colon, you will have like value. Okay, that's something you want to store. And whenever you have to access any of this element, you just have to like add that key, means w, and inside the square bracket you just have to add key over there. Okay, and it will just run and it will return 2 value to us. So basically these are like primitive procedural primitive combinations of data structures. And if we go further, we will also see like how exactly to create stack, queue, then linked list, and like advanced type of data structure, but that's something we'll study next week. But yeah, these are like simple data structure that one will have when they combine basic primitives together, basic data primitives together. I hope you are clear about the data structures. We will also practice this thing in next week. But yeah, for now this is about data structures and data. But when we combine a lot of procedures, so we have seen when it comes to procedural primitives, we have like these mathematical operators, we have logical operators, we have comparison operators. When we put them together, when we stack them together, we will have like some sort of a sequence with us. Okay, and we need to follow that sequence. So first thing that you would see is like we have control loops. Okay, those control loops are trying to decide or dictate what sequence need to be followed. Okay, so you will have like 3 types of loop inside Python programming language. We have if else loop, we have for loop, and we have while loop. Okay, so whenever you have to check some sort of condition, and based on that you have to proceed. Like, okay, if this condition is true, then and then only I will perform this operation. Okay, so basically what I'm doing over here, I'm implementing if else loop. So whenever you have to implement if else loop, I'm taking just inputs over here. So just you can ignore this part. This is the implementation of if else loop. Okay, so what I'm doing over here is if this is where I'm checking condition if c equal to plus string. Okay, so if string that I have in the over here, if it's equal to plus, means that if that condition is true, then only I will implement this operation. Okay, otherwise I'll go to next part, elif. So it's kind of like else if. then I will check this condition. If this condition is true, I will go over here. If not, then I will go over here. Then if not, then I will go over here, and then I will come out of this thing. Okay. So whenever if you want to break this thing, then you can directly use break keyword over there. And even after, even if you are if you are getting some sort of error over there, and if you want to continue, then you can use continue keyword over there. Okay. But yeah, this is like simple calculator that my colleague created. But yeah, you can see I am entering first number as a 1, second number as 2, and then I need to select operation. So I am saying selecting like as a multiplication as operation, then it should give me result as a 1 into 2 is equal to 2. Okay. So basically this is the if else loop, and using that you can implement some sort of code. Okay. Then there is a while loop. Okay. So in case of the while loop, what we are doing is basically we are checking condition in the beginning, and as long as that condition is true, we will keep going through that loop again and again and again. Okay. So the thing is that in case of the if else thing, we are just checking condition only once. In case of the for loop, we will go through that loop certain number of times. Okay. Like 10 times or 100 times, means whatever number we have provided over there for loop, we will go through that thing for that many number of times only. In just the while loop, what we are doing is we are trying to combine conditions and repetitions in one sequence. Okay, so that's something we are doing. We are initiating with counter variable 0, and what we are saying is while whenever counter variable is less than 4, you should go inside this loop. Okay, and inside this loop, what we are doing, we are incrementing counter with count variable with 1 by 1, and then we are printing count. Okay, so basically what happening is at first it will print like this 1, that because if I had like put this count after this print command, then it would have started with 0, but since I have incremented it earlier, it will start with 1, and then it will go on for like that many number of times. So this is the while loop, and then here you have like next loop, that is a for loop. Okay, so before that, I would like to talk about this range command. So range command is something which is providing us some sort of list. So you have to provide like starting element, ending element, and like step between these two things. Okay, between two successive consecutive elements, and it will provide that list a range of like 0. Basically, that's like kind of iterate. So basically, that's the iterable. Okay, and you need to use like some sort of for loop to access each element of that iterable. Okay. Yeah, iterable or iterator. We will discuss that thing in next lecture. And this is a syntax to define for loop. Okay, so for I in a range 0 to 10, or instead of using range 0 to 10, you can also use u. Okay, so if you are having any sort of list with you, you can use for loop over there. And what I'm doing is I'm printing I. So basically what I'm saying is I will go through this loop recursively again and again and again for 10 times. Okay, and by default it's considering step to be 1 over here. So if I print this thing, then it will start with like 0, and it will go through that loop 10 times. And since means we have like 9 things, means if you go through that, if you do incrementation on 0 for like 10 times, you would reach to that point. Okay, so that's that about for loop. I hope these loops are clear to you. Control loops, whenever you have to check condition, and based on that you have to do implementation, you will go for if else loop. Whenever you have to repeat or perform particular action again and again for certain number of times, you will go for loops. When you have to combine these two things together, condition plus repetition, you will go for while loop. Okay, and there are more commands over there, like you can use encapsulation, or like some means all those principle over here. You can do bigger task out of it. Okay, using this for control loop. Okay, but that's about combination that one will get when they combine like a lot of operations together. I hope that thing is clear. The next thing is abstraction. As I mentioned, whenever we are having some sort of data types or data structures, whenever we are having like composite data with us, or whenever we are having like procedural composites with us, and whenever we have to use them repetitively, we need to assign some name to that. Okay, so basically using that variable a is equal to, we are doing that abstraction for data. But when we have to do that thing for some sort of sequences, we will do define function. So this is a syntax. So we will use keyword def, then we will write name of that function. So it's like you can write any name over here. It could be anything which should be indicative of operation or method or procedure that you are doing over here, and then name. So basically what you are doing is you are providing some sort of argument over here, and then colon is something you have to use over here, and then print. So basically this is a function. What it will do, it will like print this argument over here. And then what you are doing over here is you are explicitly providing input, like we mentioned, like you need to provide. So basically this is this part is a definition and declaration of your function, and this is where you are calling that function, okay, with certain argument. And when you do that thing, it will like print name Kumar, okay. So this is about that abstraction part related to procedure. And then last part, that's related, that's where we are combining abstraction of data, abstraction of procedure, and we are trying to solve simple process, okay. And that's something we can do using class, okay. So what we are doing over here, we are beginning this thing with class keyword. Then I am giving like some name to this class. So I'm like, you can write anything over here. So you can give any name for that particular class. So I'm writing class Mayur, then colon. Then inside this thing, so this is like body of that particular class, okay. So basically, whenever you write class, you need to consider two things. You need to write first method. Basically, that's something called as a constructor, okay. So this is like constructor procedure. So basically what it's trying to do, whenever you call class Mayur, it will try to, it will by default will go through that procedure and will try to set up some basic attributes, okay. So whenever I call class Mayur, it will try to follow this, it will try to execute this function, and then it will try to set this variable A and B. And since this is about class and this is about object, we are using this self as like some sort of keyword over here, okay. So what it's saying is like basically all these variables, means all these attributes are related to me only, okay, means my class only, okay. Then you have like some another method over there, okay. So since we said like class is something where we are trying to combine attributes and methods together, okay, or data and procedures together. So basically I am having some procedure over here, and what I'm doing over here is I have written function to perform addition, okay. So what I'm trying to do, I'm trying to add A, B, and C together, and C is something I'm trying to provide externally. But this is a procedure that I have written, and this is not a constructor, okay. This is like some sort of standard procedure. This is a sequence of operation where we have like addition as a basic primitive operation. We are trying to do two additions. So like this is like some sort of composites, and then we are putting them inside some sort of definition. So this is where we are like means where we can call this entire sequence using this addition name. And when we call this, when we create instance of this class, we would be able to like get that particular task done, okay. So basically that's like, and when you create that instance again and again, basically that's something I'm referring to as a patterning, okay. So this is like implementation of particular class. So you will start with class keyword, then you will have first function over there, that's something called as a constructor, where you will list all the data and all the methods. Generally, in case of the C++ programming language, when you try to create constructor, you try to list down all the function definition, okay. That's something you're gonna need for your purpose. And then you will have function definitions, sorry, declarations. So this is something happening over here. And once we are done with this declaration of that particular class, and when we want to use that class, what we are saying, we are trying to create instance of that class, okay. So this is a class Mayur, and I want to create instance of that class, okay. So what I'm doing is I'm using this command if name equal to main. Basically what I'm saying is my execution of code should start from this line, okay. And then I'm calling this function Mayur, I'm calling this class Mayur, and when I run this thing, when I execute this line, it will create instance of class Mayur, and that instance will be known as me object, okay. So basically in case of the object oriented programming, or whenever you try to create class, basically you are creating objects, okay. Let it be attribute, let it be methods, but basically eventually you are trying to creating object, okay. Because object oriented programming is something closer to the processes that you see in the real world, okay. So the way we are dealing with some sort of object, let's say I have a bottle on my table, okay. So the way I can play with that bottle, I can like pick it up, I can drink water out of it. So all these are like procedures or operations that I can do on that thing, but basically it's an object. In similar way, this class is something which is encapsulating all those attributes and method together and letting me deal with that thing in like at a one time, okay. So this is something I'm doing by creating instance of that class Mayur, and that's something will be stored in me object. And then whenever I have to call any of this method, I will go back to like simple principle of that object-oriented programming. Like we have encapsulation, we have abstraction, then we have, so abstraction is something happening over here, okay? So I am basically calling method addition from this class Mayur very easily, right? I don't need to do this entire declaration, like say A plus B plus C. I can just write it in name of that particular function or method, and I can provide some input over here, okay? So, and this will give me output like 5 plus 2, 3 plus 2, 10, okay? So this is like first instance. That is the first pattern, okay, or first template. Then I can also create like second instance of that class, and by with like different input, and it will be stored in variable V, and if whenever I'm printing it, it will like second template, and when I combine this thing together, I would be able to solve like bigger problem. So basically that is the patterning principle of our thing. And in case of the object-oriented programming, we have property called encapsulation. So basically this is the encapsulation. It means we are encapsulating all those elements which are repetitive. So that's the encapsulation. Then there is abstraction. Whenever I have to create instance of that class, and whenever I have to call that method, I don't need to write entire declaration while calling that class or creating instance. So basically that's the abstraction property of object-oriented programming. The third thing is inheritance. So I would be able to, whenever I'm creating inheritance, I would be able to inherit all the properties and methods associated with this class Mayur, and that's something happening, and that is the third property of like object-oriented programming. And then fourth property is polymorphism, means using same template you will be able to perform different things. Means using this template you are able to get result 10, using this template you are able to get result 12. Okay, so basically you are creating different instances, and basically this is a polymorphism. Means there is a single thing, this is like single object, but you are trying to identify, recognize that thing in different form. Basically you are trying to have multiple faces for same object. So basically that's the property of polymorphism. And when you combine all these things together, you get like simple and really UOL framework. That's something we call as object-oriented programming. That's something we will see in detail in next lecture. But yeah, that's something letting us solve really bigger and complex problem very easily. Okay. There is one more thing that's remaining. I'm sorry for guys for being late. Then this is the second thing. Okay, so whenever we have to deal with any sort of, whenever we have to do file handling, whenever, so you can use this command. Okay, so with open, you can open this a.txt file. You can provide like access over here, permission, whether you want to read, write or something. So I am writing over here using W keyword, and I'm opening that thing as a yup variable. Okay, and what I'm doing, yup.write. So basically I'm trying to write something over here. So I'm writing I am Mayur as the first line, then I'm writing second line, and that file will be created. So earlier there was no file, but when I write this thing, a.txt file will be created, and you will be able to see this thing over here. Okay, I am Mayur, I like Python. And whenever you have to read that thing with open, so basically thing is that whenever you open in a file, you are supposed to close that thing. I am really not closing this thing, but whenever you use this thing with keyword, that file automatically will be destroyed from your like memory space, and means that something will allow your code to run faster. So this is the second thing. So whenever you have to read, this is about this with thing. Whenever you have to read that file, what you will do? Open a.txt with permission R, and again with keyword, so that it will be destroyed once that reading is done. And I am opening that thing as a yup variable, and I'm trying to read that thing. Okay, so yup.read, that is a method associated with that thing. And whenever I'm read it, it will show I am Mayur and I like Python. Okay, so if you consider, if you look at all this tutorial, then what the thing that you have learned is how to write to console, how to read from console, how to write a comment, how to declare primitives, how to do combinations for data and procedure, how to think about control loops, how to go further and do abstraction in the form of variable or functions or classes, and then how to do file handling. So these are the important things that you will see inside any programming language, and in our task, at least these are the things that we will need for our tutorials. Okay, I hope these things are clear to you guys. Do you have any question?
Hey Mayur, yeah, it was good. It was quite clear. I just had a doubt with the B, the section B, where
This
I tried running. No. The like B in section B, the code all the way up, all the way up.
very section B, which one?
Like up top, like after the first one, you defined Mayur as a
Commenting section.
Yeah,
Oh,
command to
over
manage.
here.
Yeah, this is the one.
Okay.
So, I mean, what do you do here? I just wanted to understand this part of.
Okay, you want to understand it again. Okay, so basically thing is that whenever you are trying to, whenever you have written code and when you want somebody else to read that code with ease, so in that situation, you try to provide some sort of explanation. Okay, so instead of writing this as like print welcome, I could have written like, I'm trying to define some function Mayur, which will provide or return some value a, which is equal to 2. Okay, so this sort of comment I could have written over here. Okay, it will return value, Okay, so this means this is a simple comment that we can write at means whenever you are trying to do any operation. Okay, but thing is that this is for like single comment. But when you have to like define, when you have to like provide proper description for your description of what exactly your function is doing. So in that situation, you provide like doc strings. You prefer doc string. So basically, it's like 3 inverted pairs, and basically this is something allow you to do that entire means explanation of code to be added over here. Okay, so you can
So
provide,
if I call Mayur, then it should return me with hello friend, do you study art? That's what you
no,
said, right?
it has not
You're defining
written. No, it will not return. So it will like neglect this thing since this is a comment.
Okay.
So that's something I'm saying. Like whenever you have to like comment single line, you would use hash function. Whenever you have to like comment multiple lines, you would use like 3 inverted these things. And using that inverted commas, you would be able to like provide like doc string over here, and that's something can be means in general people use that thing to provide explanation of your methods. Okay, they will mention, okay, for this method you would have like this sort of input, this is a process, and this is output. You might have noted that thing inside several Python codes. So basically this is the use of these doc strings, and those doc strings means anything inside this doc string will not be executed. That will be considered as a comment, and that something is happening over here. Means I have means if those 3 doc strings were not there, and if I had like written everything inside like single inverted comma, in that situation it would have considered that thing as some sort of string. Okay, and it would have given that entire thing over here to me as output.
Okay, thanks.
Okay, so yeah guys, yeah, I hope that thing is clear to you. So guys, that's all about today's lecture. Okay, I hope this
people available on the drive.
Yeah, obviously I will means I have recorded it. I will upload it to OneDrive today or tomorrow. Okay, but yeah, this is all about today's session. And this is something should give you idea about any programming language, how exactly those programming language are formed, and in what way you can like keep them in like your head properly. Okay, and like just not forget on what way like those programming language are built and how to use them to solve a particular task. So that's all about this session. That's something I wanted to convey. Like what's the way in which you should use this knowledge to like solve your real problems. So that's all about today's session. In next session you can expect information about programming styles. We will discuss about procedural programming, we will discuss about functional programming, and we will discuss about object oriented programming in detail. And then we will see how exactly dynamic processes can be solved using state machine. So this is something you can expect in like next tutorial, and we will have like accompanying tutorial as well over there. Okay, so we will have theory part and then we will have tutorial. But yeah, that's all about today's session. I hope this thing was like helpful to you in making certain thing clear to you. Okay, guys, do you have any question? If not, then probably we can like close this and we can meet again on Friday. Okay, but yeah, there is one more thing that I forgot. Okay, so guys, so we will share one link with you. Okay, so this is something called as like means this OneDrive folder link. So you have like this HOC folder over here. That link will be like conveyed to you. So you have like introduction to record means the last session that we did. So that part is added over here. So that recording is over here. So you can go through that thing, means whether you want to go for autonomous mobility or mobility, or if you just want to know about curriculum, then you can like check out that session. And if you want to go, if you want to get information, or if you want to access any of this resource that we are using for this program, then you can like go inside this autonomous vehicles thing and you can access that content. So all the lectures will be added over here. So I have already added first session. So I mentioned in the beginning, we will add like 3-4 sessions. So I have added first session on intro to autonomous mobility over here. So you have like PPT over here and lecture over here. So that's something you will find inside AV lecture. I will upload 32 lectures over here. Okay, that's something you have to go through. Then second thing is all the tutorials will be added. So today's tutorial is over here. So apart from this recording, apart from this thing, I have also added some reading assignment for you. Okay, so I'm expecting you guys to read all 3 of them. Okay, so you are supposed to read that as well and practice the tutorial that I shared with you as much as possible. And then this is like a third tutorial that we will be doing about cross. Okay, so that's the like next part. And the individual, you are supposed to create your like folder by your name inside this individual project, and you are supposed to upload the thing that you will practice on HackerRank and LeetCode inside that individual project folder. Okay, and the guided project using MBD approach will be stored over here, and then you will do your individual project inside that research phase, and you will again upload inside your own folder. Okay, try to create folder by your name over here. Okay, and try to add your info, try to add your assignments over there. Okay, so that's the first thing. The next thing is about HackerRank platform. Okay, so go to HackerRank, try to create your account over there, and once you go over there inside HackerRank, you will see this sort of things. Okay, so you have to go inside this Python basic or data structures and algorithm, and you have to solve like one question daily. Okay, so if you go this if you proceed with this entire procedure, you would be able to like get some question towards end, and you have to solve one question daily, and that's something you have to upload to this folder where that's something you have created inside this individual project directory. So that's about assignment. Then apart from that, what I'll be doing, I'll be sharing our MIY series with you. So it has around like 15 modules over there. Okay, so what you need is I'll share that mail with you. But what you need to do, you need to click on that link, so that something will navigate you to our Doorlay Controls website. Then you need to add voucher code over there. That's something we will provide you, so that you don't need to pay again. You need to use that voucher code to redeem that entire series, and then it will be like in your like bucket or the cart, and you need to go through that entire MIY series in next 1 month. Okay, so for each week you have to complete at least one MIY series, which will have like around 3 to 4 modules. Okay, so that's something you have to complete. Means you have to complete at least first MIY series by the end of this week. So these are your assignments. I hope these things are clear. First thing is you have to read all those assignments which are there inside this AV lecture, AV tutorials inside this thing. Reading assignment, you have to go through all of them. Second thing that you have to do, you have to access that MIY part, and you have to complete at least one MIY series. Okay, and apart from that, the next thing that you have to do is you have to go through all the lectures that I add over here. Okay, at your own pace. I will add like 3 lectures over here by the end of this week, 3 or 4 lectures. You have to go through that apart from this like tutorials. Okay, so that's like additional thing that you are supposed to do. I hope all these things are clear to you guys. Do you have any question? Guys, I'm trying.
No
I'm just trying to
questions
as
from me.
fast as
And only
possible.
one thing actually. So I understood the things, but only one thing is sometimes if we miss the lecture, like maybe because since I'm a working professional, in that case it will be available the next day, and I can view and cover up with the pace, right? Like
Yes,
if I
yes.
miss in that case, yeah.
Yes. I
Or
will
if any
add those.
assignments or specific information, then I can just follow, like in case if I miss also, and there'll not
Yes,
be any
yes.
break, right? That I wanted to ensure, because
Right. I will add
Thank you.
all those recordings over here. You can go through them. And if you're having any doubts, you can put them on our WhatsApp group. Or if you're having like really genuine question, if you think you want to discuss that with me, just call me and like we can like discuss that thing. Okay. I'm already
Yeah,
always available to like help you. Okay. Yeah, that's
Yeah,
all
thank
about
you.
today's session and like this part. I hope all of you are clear about that software engineering part. Try to go through those reading assignment and try to practice as much as possible on HackerRank platform. Okay, that's all about today's session, guys. Thanks a lot for joining, and yeah, good day to all of you. Bye. See you again.
Yeah,
Thank you
thank
so
you.
much. Bye.